This is Jacob Arnold, your host for On the Ocean. Harmful algal blooms, also known as red tides, in the Gulf of Mexico are predominantly caused by the algae species Karenia brevis. Blooms of this toxin-producing alga occur almost annually in Florida, but less frequently along the Texas coast. A rapid increase in the number of K. brevis cells in a region can cause discolored water, widespread death of fish, and can impact human health. The toxins produced by Karenia brevis can be released into the air, causing breathing difficulty, or they can be accumulated in filter-feeding shellfish, causing neurotoxic shellfish poisoning in humans who consume the contaminated shellfish. Therefore, it is very important that fisheries and beachgoers are properly warned of these blooms. So the prediction of HABs for the Texas coast is a critical subject of scientific research. Using historical data from the past 20 years, researchers have found that measurements of the intensity and duration of alongshore winds were correlated with occurrences of Karenia blooms. Specifically, the alongshore winds create what is known as downwelling conditions. Downwelling occurs when the surface waters converge. In this case, convergence occurs when the surface water is moved toward the coast, and this pileup pushes the surface water downwards. The convergence and consequent downwelling at the coast concentrates Karenia cells. The correlation of specific wind conditions and bloom occurrences can allow researchers to predict a Karenia bloom. Monitoring and prediction of HABs is not only important to detect human health, the effects of HABs can also cause many economic problems if shellfish harvesting is closed and by negatively impacting local tourism. Toxic HABs blooms can shut down beaches for discolored water or for smelly piles of dead fish, and this can ruin a tourism-driven economy for weeks to months at a time. This has been On the Ocean, a program made possible by the Department of Oceanography and a production of KAMU-FM on the campus of Texas A&M University in College Station. For more information and links, go to ontheocean.tamu.edu.